Well, here we go again. If you have hung around to this, the fourth instalment, thank you very much. I'm slowly working my way through this coil, and I think we're getting somewhere now. I've got the transmit coil free from the plastic, and sure enough, here are the two wires that I mentioned earlier about, the ones that are going into this outer coil. Now this is all wrapped up and it's quite nice. It doesn't look like there's any space there or any sort of movement between the windings. It's all pretty tight. However, we haven't seen inside yet, so we need to open it up and have a look. So I was thinking that I can cut this and then reinstall this material later. I do have some of this fabric tape that I can put back on later. So here we go. It is an adhesive tape. So I'll open up one section and it should peel off pretty easily. I don't want to scratch the insulation on the individual bundles because it will create interference within the system. So I've got to be very careful not to damage any of this. So I'm being rather careful. And so here we go. We can see now the bundle is opening up. And so there he is. We've got all of the different layers now. We'll be able to work out how many turns there are. And, she's well cemented together by the looks of it. So this has been put together very nicely. Unlike, in my opinion, the receive coils are a bit crappy, but these ones here, they look like they're put together quite well, and they've probably used some form of adhesive to hold them together so that they don't move around, because once you pulse this with a high current pulse, you'll have electromechanical forces applied to the coil. If there's any movement at all, it's just going to rattle and create interference, and we don't want any of that. So this looks pretty impressive, actually. This is good. So this will, oh yes, all laid up in layers. I don't want to damage it. I would prefer basically to keep this hole the way it is in its individual parts, and then use it as a reference going forward. So once this coil is completely dismantled, I will pull apart the 14-inch coil as well, because I don't use it either. So I only used it when I first got the detector. This one here I used very sparingly because it just didn't do the job for what I wanted anyway. Most of the ground that I detect in is quite shallow ground, and so there was no benefit in having this big coil. For me, for other people who are going into the deeper ground, maybe, they're talking about these things detecting down to 1 metre. I don't know if you've ever dug a hole 1 metre deep in any ground, but try to do that in partially cemented goldfields ground and you'll find there's quite a big difference in the amount of effort required to dig one of those holes. And that, you're talking about a whole day, and you get down there and you think, while you're digging, you think, oh my God, this is a bit of virgin ground. No one's been here before. And then you'll get down 1 metre, and we've done this. We did this around a place called Maya, and my mate dug down and it was deep, you know, it was a metre deep, and he gets down to the bottom and it's a bloody can. You know, and you think, how is it possible that a modern can is down that deep? And just not to mention, you know, going down into where the old timers are, you've got to understand that these guys, the quantity of people that were in the goldfields was massive. So there was an area called Vaughan near Chewton. There's a valley there, and it's it just looks like a normal valley full of grass and cows and all that sort of business. But we were told that they had cleared out the ground in that valley to a depth of 150 feet. So that's a long way down. And this was before machineries or any machine or anything else. They were digging this stuff by hand. And, you know, when they moved from one area to another, it's like when they moved from Ballarat to Bendigo and Bendigo to Ballarat. You know, any time that they heard there was news about a new area that has opened up and, you know, there's the possibility of gold, they would just pick up and you'd have people moving into an area, 60, 70,000 people in one hit. Well, just imagine if you've got people with picks and shovels, 60 to 70,000 people, hungry people, all right? These are people who are doing this because they wanted to make enough money to buy food and to support their families back home. A lot of the early guys were, you know, sending money home to support their families in countries like Ireland and Spain. And you have a look at all these different areas, especially around Ballarat and Creswick. They have names like Doctor's Gully, Spanish Gully, you know, Irishman's Gully. There's a place called Irish Town near Chewton. So all of these different cultural groups were sending money back to their homes to support their families, and so they weren't doing it just for fun like we do. They're doing it because they have to. And so you dig a hole like that, and you'll see how much dedication is required to be an old-time prospector. Now, we have, you know, cleaned out old diggers' holes just to have a look what's going on, you know, because after 100 years, a lot of the debris that's fallen into those holes is quite deep. And so we have one mate who makes a point to go out and clean out those holes and have a damn good look at it. So, you know, it's a strategy for some where they go in, clean out the old holes and have a look to see whether or not the adjacent ground has been opened up before. And, you know, I've done it myself and found that, you know, that the lease would have been, or the rent that was given to the diggers would have been for a plot of land, and so they would dig down and cast all the soil aside after they've checked it, and then dig next to the hole that they just dug. So all of the stuff that they've just dug out of the first hole is on the side and becomes the mullock, and then they put that stuff back in the hole, and then they dig next to the hole they had. So if their hole was, say, you know, 1 metre or 2 metres in circumference, that material will get thrown out of the hole and then put back in the hole after they've gone through it all, and then they'd move over a little bit and dig that hole. And so you can go into these areas and you're actually seeing the last holes that have been dug in that area. There's a very high likelihood that the whole place has been turned upside down. So there's not much in the way of virgin ground in the actual goldfields areas. What we call our gold is it's like it's forgotten gold or lost gold, because the guys, you know, they'll put all this stuff in a wheelbarrow and take it and process it. And so you end up with, you know, the dropped gold, the stuff that they dropped on their way to have it processed. We found one place up around Dalesford where there's a lot of gold that's been dropped, and it's in the old cart tracks. And so, you know, quite often we'll find gold in the road, and it's because, you know, it's been transported by someone to a place where there is water so that they can go through it and find the gold. The only thing they had to use was water and gravity, really. They didn't have our fancy things like this. And I just like to say, this is a beautiful looking thing, isn't it? It's just really pretty. And it is solid, like it is really solid. So this thing has been impregnated with resin or something, and I might have to apply a little bit of heat to see if I can get these things to move. So I might try my little, very well controlled little heat source and see if I can apply a little bit of heat to it and get some movement in this coil. So I might turn it over this way. Just double check to make sure you're still online there. And you are, and I've got that position to the right spot. Great. All right, so let's see what sort of marks they've got here. L95, R275. I think that's what it says. So I might bring that down closer just to have a closer look. Oh yeah, I got in trouble yesterday. See that burn mark on the blasted end here? That was my brand new polar fleece jumper that I was wearing the other day. So I've had it sitting on the bench and I've just leant on the damn thing and burned a hole through my jacket. So the chief executive officer was not happy. It's my fault. I shouldn't have done it, but we have the technology. We can repair it, so it'll be okay. But I've got to be careful where I put this thing because the heat is invisible. Shit, that's hot. The heat is invisible. It just, I don't know if I can show you without setting stuff on fire, but it's completely catalytic converted to heat only. I'll just show you with a bit of paper. Have a look at this. It's invisible flame. There's nothing there. But as soon as I put anything in front of it, there she goes, all right? So it's very interesting. It's a flameless heat source. Okay, so I'll just make sure I've got good video of that, just so I don't forget. That should be okay. That would have been close enough. Now I'm going to cut this off and start trying to unravel this thing and see what these cryptic messages mean. So, just a dirty old bit of masking tape here, nothing special. I suppose you could call this a maker's mark. It's something that they've done during their construction process to ensure that it's being made to their design. So I'm sure every single one of these would be individually tuned. It's not something you just say, oh, well, bulk, make them like this and Bob's your uncle. No, these things would be all individually tuned. The tuning between the transmit coil and the receive coils is critical because you need to have a level of blanking, just inherent blanking of this coil from the transmit coil. So the receive coils during the transmit process have a snubbing circuit which blocks them out for that period when the pulse is sent out. And there'll be some level of delay because the signal would take time to propagate. So if I'm sending a signal down It doesn't happen instantaneously. It happens over a period of time. You know, it's only in microseconds, but it still is time. And so they need to be able to make sure that during that transmit pulse, when it sends this pulse down into the ground, that these coils are not receiving that pulse signal. And a lot of that will be with shielding. And so if I just flip this over now, just to show you the shielding I'm talking about, because it becomes apparent now when we pull this thing out. Very gently. Come on, you can come out of there. There it goes. I'll just cast this aside and I'll get my pointer. You can see here we've got this painted region on the base of the coil. It doesn't go up too high. They've only done the lower section of it. But this is conductive carbon paint that's been gooed in the bottom here, and there's the trace wire here that's actually running along to create a continuous grounding or a shielding region. And so that means directly below it's being shielded. I'm going to be really interested to see once we start doing some detection of the signal. So these coils here and this coil, the relationship between these I'll keep exactly the same during the test, but I'll introduce an additional coil that I'll be able to put stationary somewhere and then use that back into the oscilloscope so we can actually detect the signal that's coming from here, and then doing the same thing and looking at the reflected signal back into the receive coils. So I don't know about you, but I'm excited. I reckon this is going to be a bit of fun, especially for my interest. I think it'll be a good little exercise to see how these things are built and give us a bit of an idea of how it all goes together. So let's see what we've got going on here. Okay, it looks like one of them is starting to come free at some point. Oh yeah, it's definitely impregnated with some sort of resins, I think. If I can see, I'll just place a bit of heat on here and see what happens. Oh yes, yeah, I can see it now. It's a lacquer. So it frees up very, very easily. Okay. As long as I'm careful, I should be able to unwrap this coil and then carefully have a look at how it has been wrapped and then put it back exactly the same way that it came out. So if you have a look here, if I apply a little bit of heat just on this part of the winding here, you can see now it's coming out away from the coil, from its wrapping. Very, very carefully. Okay, so that's as far as that'll go. For the other one, the one that's on the inner part of the wrap, so they've started on the inside and they've wrapped around. But they've wrapped around very, very nicely. It's actually beautifully done. It'd be interesting to see if they've actually made some sort of coating over the windings to start, and then once they've put it into the former and given it a bit of pressure, whether they've applied a vacuum to it and a bit of heat to actually make it turn into this conglomerated wiring. Because I can tell you now, this is really worth the effort doing this. I'm getting a lot of insight in how these things are built. I'll just turn my heat off. So you can see here I've been able to undo this wire, and you can get an idea of the configuration of this wire. And you see here how they've twisted it. So that twisting there would actually help cancel out during this area here. The more twists, that you have in this area here, the more it would cancel out. So you have this like if you look in communication cables, that's exactly how they do it too. They twist the wires, and depending on the frequency you're dealing with, well, depending on how many twists are required to cancel out. So I think that's it for the moment. I'll keep going on the other parts. I still haven't got to the central bit here. That's been a bit of a challenge, and that I just need to concentrate on that and get that finished so that I can get this coil away from the detector coil frame. And once I've got that apart, I'll then take the two receive coils out, and I'll get a big piece of either fibre, the fiberglass board like they use on circuit boards. I can get that without the copper and get a big piece of that, attach some brackets to it so I can attach it to the 7000 shaft, this little guy here, and I'll probably end up 3D printing the mounting piece. So when I do that, I'll make sure that I go through the process and show you how I 3D print. I'm not an expert, but I've done a bit of 3D printing, and I'll show you the process of actually making up the drawing, and then how you can then go ahead and develop your own stuff. Now, I do have some different materials, and I've made a machine that is capable of printing something that's 400 millimeters by 400 millimeters by 500 millimeters. So it's quite a big printing format. I'll try to do it myself, but I won't be shy to go and ask someone else to have a go too. So if someone's got a machine that would like to get involved in this process, then we could maybe talk about it if you leave me a comment and a way of contacting you. But I think making something using 3D printing as a development tool is just such a bloody good thing. I've built some really nice things with the 3D printer, and one of them I built was the stand for the Gold Monster and the Equinox, so you can have this little stand to stop the thing tipping over every time you put it on the ground. The other thing I'm looking to develop using TPU, which is a flexible material, is a shock absorbing mount to go on the bottom side of the GPZ 7000 and incorporate that into a housing, into a case, so that when you put the thing down on the ground, that you're not smacking it down on the ground. Like if you drop it just like that, that's enough to affect the connections on the circuit board, and they're notorious for having loose connections within the boards. So when we go and do that process, we'll probably do a G-force measurement as well. I might use something like the phone and mount it onto something, and I'll drop it and measure the G-forces before and after the shock absorber that I make for the 7000. My 7000 is probably out of warranty now, and it has had a couple of repairs done to it. It's still got an ongoing issue that's not causing me a great deal of problem, but it's not perfect. And so one of the things I would like to do too is get inside the 7000 and have a bit of a play around. Not that I'm going to be doing anything too risky. It's too much money to throw down the drain for the technical experience of doing it. So I won't be doing anything silly, but I certainly will be looking at the construction within the detector, pull each part out, the boards out, and have a look at how the connectors work, and whether or not, pardon me, the detector, can be improved by some simple structural changes within the detector. All right, thanks very much for listening. We've had a look at our beautiful shiny coil. I'll get to work on this and get all of this crap out of here so that we can have a good look at the connection made between the flexible cable and the transmit coil. and also I'll get rid of all of this material out of these two here so we can free these coils as well. So that's where we're at the moment. Thanks for joining me, and if you like this content and you aren't subscribed, can you please subscribe and give me a like. If there's anything you would like me to do in the metal detecting field, I'm up for, you know, maybe doing some other things too. Maybe some of the older detectors, having a look inside those and having a bit of a play around. I am in the market for a 4500 or a 5000, so I'm looking for one to come up on the right price so I can buy one. I think I've had the 7000 for a couple of years now, and I think I've still made more gold, or found more gold, with my 4500 than I have with the 7000. But I had a year off because of health things and whatever. But I do think that the old detectors are really good, and that we should probably have a revisit there to make sure that we understand the full capabilities of those old detectors. There's still a lot of guys out there finding a lot of gold with the old 45s and 5000s. We've got a mate who had all of the detectors and had any opportunity to buy what he liked. He's running around with a 45 and a big coil. So we'll have a look into that as well, and maybe interview some people and try to get an idea of what their thoughts are. All right, again, thank you very much, and I'll see you on the next one.